Hi everybody, let's talk about problem solving and some different strategies for this. We're always solving problems throughout life, and the ones that involve numbers are sometimes more challenging, but there are some strategies that you can use that will make it a little bit easier on you. So we need to carry on, look at the big picture and figure out what do we need to know? What is the problem asking us for? Do I understand what's going on? We talked about in 1.1 about reading and making sure that we look at the big picture as well as the details to understand the problem. Then we need to devise and carry out a plan. Again, there are a lot of different ways to do that. We're going to explore just a couple of different kinds of ways to do that. The first one is going to be listing strategies. Sometimes it's important to know all the ways that an outcome can occur, and an outcome is a result. What are the possibilities of what would happen if I make this decision or this decision? And we want to be systematic about it. One of the easiest ways to do this is to make a tree diagram. And an easy way to look at this is by flipping a coin. Okay, if we're going to flip a coin, you can create a tree diagram, and we're going to answer some questions along the way. So if I flip just a single coin, then my outcome can either be a head or a tail. Okay, those are the only two possibilities. So if I'm flipping one coin, there are two possibilities, either a head or a tail. But what happens when I flip two coins? Well, we already know that the first one can either be a head or a tail. If the first coin is a head, then the second one can also be a head, which would give us the combination head-head, or it can be a tail, which would give us the combination head-tail. Now, if on the first coin we rolled a tail, we still have two possibilities for the second one, either a head or a tail. So we would have a tail on the first, a heads on the second, or they could both be tails. So if I look at this, there are four combinations: head-head, head-tail, tail-head, or tail-tail. Okay. Well, let's see what happens when we flip three coins. We've already got these four starting places. So from our first two coins, our answers are set. It's one of these combinations. But then for our third coin, we know that when we flip it, it can either be a head or a tail. So for each one of these, it can either be a head or a tail. It can either be a head or a tail. It can either be a head or a tail. So now if I list these combinations, if I started out with heads, heads, I could have another head. So the possible combination here would be head, head, head. Or if I threw a tail on the last one, it would be head, head, tail. And you can see I'm going to do that all the way down. I don't know that I'll do them all out loud. Head, tail from the first two rolls, and then the third roll is a head. Or a head, tail from the first two rolls, and then a tail on the third. So we can follow the rest of these. This would be a tail, a head, a head, a tail, a head, a tail. The first two are tail, tail, and then either a head or a tail, tail, and then yet another tail. So if I count these up, there are 1, 2, 3, 4, 5, 6, 7, 8 combinations. 3 heads, head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, or tail, tail, tail. Okay, but what are we going to do if I want to flip 10 coins? Well, I could continue this on out for a 4th coin and a 5th coin and a 6th coin, but you can tell it's growing. So we might want to find a different way to do that. So I want to be able to look at what happens with a 1st, 2nd, and a 3rd coin and see if I can find a pattern so I don't necessarily have to do that. Okay, so relating to other problems or trying a simpler version of the problem is basically what we want to do here. What we've done is we've created, if I want to start it out wanting to know, well, how many combinations are there when you flip 10 coins, then probably maybe I could find a pattern because I don't want to spend all day doing that. Okay. So the number of head-tail combinations in which you flip 10 coins is over 1,000. Yikes, I absolutely don't want to do that. So trying to find the answer could be challenging and take up a lot of paper, but we started with an easier version of the problem and then try to find a pattern. So let's do that on the next page. Okay. So if I flip 1 coin, there were 2 combinations. If I flip 2 coins, there were 4 combinations. If I flip 3 coins, there were 8 combinations. Now I'm hopeful that we explored this in class, but let's see what happens on here. What's going on is that these are powers of 2. Notice what I'm doing each time here is I am taking this and multiplying times 2 times 2. So if I wanted to fill out this table, if I multiplied 8 times 2, that would give me 16. 16 times 2 would give me 32. And let's see what happens with 6 coins. If I multiply 32 times 2, it does give me 64. So if I multiply 64 times 2, that's going to give me 128. Now I could continue with this pattern to find out, continue the table and say, all right, well, if I want to do 8 coins, so I could, expand the table if I had some room here, which I don't really, and wanted to find 8 coins, it would be 128 times 2, which is 256. 9 coins would be 256 times 2, which is 512. And finally, then our 10 coins would be 512 times 2, which is 1,024. So we were telling the truth on the front there, over 1,000. But let's see if we can find a pattern to this where we wouldn't even have to do all this out. Okay. Well, the pattern that I found on here is that if I take 2 and the exponent is the number of coins, that will give me my total. So 2 to the first is 2. 2 to the second, because I'm just multiplying 2 times 2. 2 times 2 times 2, that gives me 4. 2 to the third is 2 times 2 times 2, which gives me 8. And keep on going until I hit 2 to the 10th, which is 2 times itself 10 times, which is 1,024. Now, as you're doing this on your calculator, every calculator is going to be a little bit different, but if you want to do 2 to the 10th, you may have a button that shows an up arrow like that if you want to do 2 arrow 10, or you might have a button that looks like y to the x. And you're going to have to play around with yours, and we can help you with that as well, how we can get that done. Okay. Well, this brings us to the multiplication principle, which is also a different way of looking at this as well. And what the multiplication principle tells us well, let's do one more example and see if we can figure out what the multiplication principle is. Okay, so let's say that your place of employment requires that you wear one of 3 styles of polo shirt and either khaki pants or black pants. You own all 3 styles of shirts, you own 1 pair of khakis and 1 pair of black, and we want to know how many different work outfits can you come up with? Okay. All right, so let's list all the possible combinations. And so let's look at this in terms of shirts and pants. Well, I'm going to call the polo shirts Polo 1, Polo 2, and Polo 3. So I can start out by choosing either one, any of those 3 shirts. Then my pants are either khaki, which I'm going to call K, or black, which I'm going to call B. So if I pick shirt number 1, then I can either have the khaki or the black pants. If I pick shirt 2, I can either use the khaki or the black pants with those. Shirt 3, khaki or black. Okay, so let's see what the combinations are and how many there are. So the combos. Polo shirt 1 and the khakis. Polo shirt 1 and the black. Polo 2 and the khakis. Polo 2 and the black pants. Polo 3 and the khakis. Polo 3 and the black. And if I count all those up, 1, 2, 3, 4, 5, there are 6 possible combinations. Now, the multiplication principle, what it tells us, if there are A ways of doing one thing and B ways of doing the other thing, then you multiply those ways together. So the shirts, there are 3 possibilities here. There are 2 possibilities for pants, and if I multiply those together, I get 6. Whoops, and you can't see that. So does this match? Yes. Well, now let's go back and see if we can apply this to what we did on the front here. Okay, so we knew that on the front that the number of ways that the first coin can land is either head or tails. So there are 2 ways. Whoops, and I'm sorry. The number of ways the second coin can land are head or tails. So there are 2 ways. And the third coin can either be a head or a tail, so there are 2 ways there. So to find the total, it's just 2 times 2 times 2, which is the same thing as 2 to the third which gives us 8, and that agrees with what we did on the front. Okay. Now let's talk about guess and check, and this is probably one of those things that you may have struggled with, and it's usually because it's a lot of word problems. It's, like Debbie is twice as old as Mary, and Mary is, 3 times as old as David, and their ages all add up to something. So the big problem here is, where do you start? But guess and check is a very valid strategy. It may not always be efficient, but it will, chances are, get you where you need to go. The key to success in it is knowing where to start and how to be smart about it. Your first guess is usually just going to be kind of an impulse, but then being systematic about it. Okay, it says the total age of 2 turtles is 336 years. Okay, so that's what we want to know. We want to know the ages so we can get to the total. So let's see, what do we know about this? It says the second turtle is twice as old as the first. But it doesn't tell us anything about the first turtle age. It tells us nothing. But what it does tell you is that the second turtle is twice as old as the first. So I don't know anything about this, but I do know that if I know the age of the first turtle, then I can find the age of the second turtle. So to find the age of the second turtle, I need to find the age of the first turtle. Since I don't know anything about this, this is where I'm going to guess. Okay. Lots of good places to start. We'll follow along this example so we're all on the same page. Let's just guess that the first turtle is 100 years old. Okay, that's reasonable, and it's easy to calculate. So the age of the second turtle is 2 times the first turtle. So this is going to be 2 times 100, which is 200. So if I add them together, 100 plus 200, that equals 300. Did they add up to the correct total? No. Okay, so now we need to, it's kind of like Goldilocks. Is it too high or too low or just right? Well, this is too high, too low. So your total is lower than 336. So I need to make this higher. Okay. I need to make the ages bigger so they will equal 336. Okay, so here in a table is just what we did. We guessed 100 for the first one. So we were able to guess the first turtle and calculate the second turtle, because if we knew the first turtle, we could find something out. Add them together. They were too low, so our next guess is going to have to be higher. Okay, so let's see what we're going to do here. I don't want to go to 200. Let's go to 110. It doesn't really matter. Now to find the age of the second turtle, I have to multiply that by 2. We know, and that gives us 220. If I add those together, that's 330, and it is still too low. Okay, let's go to 115. It's close, but let's go to 115. Okay. Then 2 and I really am just guessing here, times 115 is equal to 230. So 110 plus 230 gives me 340, and now I am too high. So I'm going to have to go somewhere in between here. Well, halfway in between I don't want to do because that's a fraction, so let's go to 112. Then if I do 2 times 112, for the second turtle that gives me 224. So 112 plus 224 is 336, and I made it. Okay, so if I write my answer in a complete sentence, the first turtle is 110 years old, and the second turtle is 224 years old. Now this is a fairly simple problem, and you may not have needed to complete a table in order to do it, but it can certainly be helpful, and especially when you get into three things. Okay, next one. Last July, your electric bill was 2 times the amount it was in December and 42 less than it was in August. If the total of all three bills was 537, what was your bill for each month? July, August, and December. Okay, so what do we want to know? We want to know the bill for July, August, and December. And we know the total is $537. Okay, so let's see what we've got going on here. All right, first it says last July the bill was 2 times the amount in December. So the July bill is 2 times the December bill. So if I know December, I can calculate July. So I'm going to calculate this. Okay, what about the August bill? So in July, July was 42 less than August. So if July is less than August, then the August is July plus 42. So this is another one we're going to calculate. If I know July, then I can find August. So what do we know about the December bill? Nothing. So this will be my guess. And you could have done this as well. You could have said July equals August minus 42. It really doesn't matter. Okay, but our guess is going to be what we know nothing about, which is the December bill. Okay. We know that the July bill is 2 times the December bill. So if I know December, then I can find this. And I know the August bill is 42 more than the July bill. So if I know July, add 42, then I know August. Okay, once again, from here, we're just going to start guessing. I don't really know where to begin on this, so I'm going to do $100. So to find the July bill, I'm going to have to do 2 times that, which gives me 200. So there's August. I'm sorry, July. Then to find August, I'm going to take July plus 42. And when I add all those up, 100 plus 200 plus 242, that gives me 542. I wanted 537, so this is too high. Not by much, but I'm going to have to adjust down. Okay, so let's try 95. So if I guess December is 95, 2 times 95 is going to give me 190 for July. Then if I take July and add 42, that's going to give me August, which is 232. So 190 plus 95 plus 232 is giving me 517. So this is too low. Okay. Let's see. This is a lot closer than this, so I think I'll go to 98 next. So 2 times 98 gives me 196. 196 plus 42, whoops, gives me 238. And if I add all those up, and I do this differently each time so I don't have this, if I have 98 plus 196 plus 230, whoops, I get 532. And that is still too low. Well, the only place to go now is 99. So if I have 2 times 99, that gives me 198. And then if I have 198 plus 42, that gives me 241. And when I add all those up, I have finally made it. Okay. All right, and since we'll try to get through this material, I'll leave it to you to write it as a complete sentence. Okay, I'm going to switch videos.